Concanavalin A is a protein found in the jack bean and is 290 residues long. The protein structure is a tetramer, featuring 4 repeating monomer structures bound together to form one larger structure. Overall, the protein contains 20 beta strands, 3 alpha helices, and 3 turns over the entire monomer. The monomer has many metal binding sites, commonly binding manganese or calcium, as these sites must be used for saccharide binding to be possible. The domain 1CON is a single-chain domain found within the protein. The structure was determined at a resolution of 2 angstroms. Overall, the domain spans from the residues 28 to 148 of the monomer, or about half of the structure. Within the domains, there are 2 binding sites for ions, one which has the ability to bind ions such as nickel, zinc, or cadmium, and another which is specific to cadmium or calcium ions. In the case of the detected domain, the transition metal binding site was populated by cadmium, and the other binding site was taken by calcium. A third binding site was determined to be filled by another cadmium ion in this domain, although in other cases of different domains in the concanavalin A structure, not all domains feature this third binding site. The protein has no known biological function, but acts as a tool for determining the interactions between saccharides and proteins. As a result, the protein acts as a dimer in solution. The 1CON domain is largely comprised of 13 long beta strands connected by bends and a few alpha helices. These beta strands create the overall shape of the protein, as many of the individual strands are connected by short bends connecting to the next strand in sequence. As a result, the bends do not tend to extend out from the structure much and mostly just follow a straight path. Overall, these beta strands form 2 separate beta sheets with anti-parallel beta strands in both. These 2 sheets sit apart from each other with a hydrophobic area away from any other amino acids within the domain. Another smaller hydrophobic area exists below the beta sheets near the calcium binding site. There are 2 alpha helices located on the domain, both comprised of just 3 amino acids, making the helix loop only once per helix. These helices are not placed in any pattern in the domain, and as a result, the fold class is defined as an alpha plus beta fold. 1CON has 105 main chain to side chain hydrogen bonds forming crosslinks, as well as 34 side chain to side chain hydrogen bonds, which allow for salt bridges. There are 296 water to protein hydrogen bonds and 104 water-to-water hydrogen bonds within the protein as well. The average distance between all of these hydrogen bonds is 3 angstroms. The ligand binding site for S1 for cadmium is located around the residues GLU8, ASP10, ASP19, and HIS24. Not far away, the S2 binding site for calcium is connected around residues ASP10, TYR12, ASN14, and ASP19. The second cadmium binding site, S3, is located further down the protein, binding to residues GLU87, ASP136, and GLU183. Overall, the average distance of these sites is around 2.4 angstroms. The formation of the 1-con domain involved growing crystals of concanavalin A and then taking data on film at a wavelength of 1.488 angstroms to then be digitized. Any missing data was sent to be analyzed using a rotating anode diffractometer. Positional refinement was used to find the coordinates starting from 8 angstroms and slowly refined to 2 angstroms. At the point of 2 angstroms, it was repeated multiple times before going any further. As a result, this reduced the R factor from around about 44% in a previous paper to around 20%. Electron density maps were used to calculate how many water molecules were detected. This resulted in changes to side chain positions. Once another refinement had been completed, a water molecule was found to be the binding site for a cadmium ion. This resulted in the inclusion of a ligand binding site being added to the model as it was halfway through being formed. More refinement was done until a problem arose around the residues 150 to 155. ARG had to be used in the place of GLU at 155 to allow the bonds to rotate 180 degrees and fit correctly. A cis peptide at ALA 207 and ASP 208 is thought to be in the concanavalin A structure, resulting in an electron density map having to be used to confirm if the existence of this energetically unfavorable peptide existed. It is believed that a water molecule nearby interacts with this structure as well as the calcium ion. As a result, there is a possibility that the cis peptide exists in the region. This is a structure of 1-con. So starting here, there is the N-terminus, and every single beta strand is antiparallel going forward and backwards. It's got the first 3 strands at the front, then towards the back, it starts going 1 or 2 at the back and then going back to the front and looping down underneath or on top. As you can see, how I was saying, there are quite short loops in most cases, just to make up for the long strands towards the back. Where there are longer loops, like up here and down below, there tend to be some areas where there's, for example, an alpha helix. So up here there's an alpha helix which turns once. There is also one right by the C-terminus just here, so out the front as well. And the C-terminus is where the length tends to be a lot longer without beta sheets. So on the front there are six beta sheets, six beta strands, and on the back there are 7 beta strands. But the ones at the back tend to be all in one shape, whereas the ones in the front tend to bend slightly out from each other. So that's what the 1-con structure and domain looks like. Thank you.